Well, nicely enough, the second translation theorem gives us a wonderful way that we can find the Laplace transform of functions that are piecewise defined as long as we have rewritten them as some product of a function and our unit step function. Yes, that is a very nice thing. So, if f of s is the transform of some function f of t, and a is a positive number, then the Laplace transform of f of t minus a times our u of t minus a, the unit step function, is e to the negative as times our f of s, the original f of s we had. So this can be proved, not that hard to do, just replacing in the definition of a Laplace transform, we will be finding the transform of this, right, as you can see here. And that would be the transform of the function from 0 to a of e to the negative st, f of t minus a, u of t minus a. I ask you to think about what that is. And then the translation of the function on the interval from 0 to infinity of the same thing. And I think you figured it out, didn't you? This would be 0 because that's what the u of t minus a is going to do. It's going to make that function 0. So it's going to be 0 plus the improper integral from a to infinity instead of from 0 to infinity of just this function alone. And actually, this u of t minus a on that interval is just 1, so we could forget about that. So now we've got our transform of this function into the point where it's just the transform of the function f of t minus a evaluated between a and infinity. But then again, if we replace our t minus a with some other variable like v, and of course dv equals dt, so then this becomes, if we make that translation, by the way, t would be v plus a, so e to the negative s times v plus a times f of v dv. But now, instead of going from a, remember v is t minus a, so that means this would be 0. So I had a slight mistake there, but I think I got it fixed now. So e to the negative s times v plus a times f of v dv, and since e to the negative s is a constant, that factors out. And so then we have this e to the negative as factored out of the integral of e to the negative sv f of v dt, and look what this is. I mean, it doesn't matter what you call your variable, but call it v, call it t, but this is just the transform of f of t. So it's e to the negative s times the Laplace transform of f of t, whatever that may be. If you wanted to call this f of s, you could. Maybe that would be nicer to call it that. We'll say times f of s, right? That might be a little more convenient. So in other words, if you want to translate something like this, right, that's with the unit step function from a certain point, then it's just e to the negative as times that standard transform. So, an example, find the Laplace transform of u of t minus a. Well, recall that the Laplace transform of 1 is 1 over s, so this is going to be, instead of 1 over s, e to the negative as times 1 over s. Too easy.
I think he's brilliant.
Oh, thanks.